Hi, welcome back. In this session, we're going to deploy an example application on top of our workload cluster that we deployed in our previous section on Cluster API for vSphere. So before we get started, a quick recap on what we've accomplished so far. So in our last two-part session on Cluster API for vSphere, we used our management cluster to create our workload cluster with a single control plane, master node, and 5 worker nodes in our VMC environment. So currently we have a working workload cluster in VMC, and now we're ready to deploy our applications. So the first thing we're going to do, we obviously have our EMEA VMC SDDC as well as our workload cluster that's going to serve as kind of the platform for this service. And I wanted to show kind of a complete diagram of the finished product of our application. So we're going to deploy a WordPress application that utilizes a MySQL database as a backend. We're going to go through the process of creating a secret as well as persistent volume, because both of our deployments, the WordPress front end and the MySQL backend, require persistent storage for their volume. So the first thing that we're going to do is create the persistent volume claims. Now, our workload cluster in VMC is configured with the vSphere CSI provider. So what this means is when our developer creates a persistent volume claim, the CSI, the vSphere CSI provider, communicates directly with the vSphere storage to create a VMDK that will support and back a persistent volume that will then be bound to a persistent volume claim. So this process is automated. So let's take a look at the YAML file for a persistent volume claim. So we're going to define a storage class that was created for us by our admin. So our admin created a storage policy in VMC and then a storage class that's linked to that storage policy in VMC. So anytime a persistent volume claim is created from that storage class, VMDK is created in a data store that is within compliance for that storage policy in vCenter. So we pass the YAML file to our workload cluster, and we can see that the VMDK is created and linked to the persistent volume, and then the persistent volume claim is linked to the persistent volume is linked to the persistent volume claim. We're going to do exactly the same thing for our MySQL volume. So pass that to our workload cluster. Our VMDK volume is created, linked to our persistent volume, and then linked back to our persistent volume claim. So now we've got our persistent volume claims for both deployments created. Now the next thing we need to do is create our secret. So we need a root password for the MySQL service, and we also need for our WordPress front end to be able to access our MySQL service and access the database with that same password. So we're going to echo our password into base64 and then create a YAML file for our secret that includes that base64 encoded password. So we're going to pass that YAML file with kubectl to our workload cluster, and now we have our MySQL pass secret. So now we're ready to create our WordPress deployment. So if we have a look at the WordPress deployment file, and it's kind of long, so this is the first half of it, we will define things like the number of replicas we want, the labels. So for instance, this has two labels, app WordPress and tier front end. So this is the front end of our WordPress application. We're also going to define what containers we use. So we're going to use the WordPress image that we have stored locally in our private container registry. And we're also going to need to define the secret that we created earlier as an environment variable in our deployment. So if you have a look at the highlighted text in the deployment file, we have an environment file, an environment variable, WordPress database password, and we're going to get that value from our MySQL password. The key password and the value is our base64 encoded password from earlier. So we've done that, but we also need to connect our WordPress deployment to our persistent volume claim. So in the continuation of our YAML file, we have the volume mount that specifies the volume tied to our persistent volume claim. So now we have our WordPress deployment connected to the persistent volume claim as well as the secret. We're going to do very much the same with our MySQL deployment. We define our label. If you notice, our app still WordPress, but our tier here is MySQL, so it defines our database so we can separate with selectors in the later action. If we look at the environment variable section of the deployment file, we're going to create an environment variable in our MySQL pod, MySQL root password. So when MySQL pod boots up, it's looking for a root password, it queries the environment variable, it gets the password from our MySQL password secret. Just like the WordPress deployment, we also need to connect the MySQL deployment to its persistent volume claim. So we create a volume mount in the deployment file that references a volume that's tied to the persistent volume. So very similar process and requirements for both deployments to connect and mount the secret as environment variables, as well as mounting the persistent volume claims as volumes within the container. So now we need to create a service that allows the WordPress front end to utilize the MySQL backend as its database. So if we have a look at the service YAML file over to the right, we're using the selector value, the label selector, to ensure that this service sits in front of any app that is labeled app WordPress tier MySQL. So this service is providing an endpoint for the MySQL service. But how does our WordPress deployment understand where to look for the service? So if we refer back to our WordPress deployment file, we also defined an environment variable with name set to WordPress-MySQL. So within the Kubernetes cluster, the services are automatically assigned and managed. DNS is automatically managed with core DNS in our case. So WordPress is looking for some service named WordPress MySQL, which we created previously. So that allows the deployment to access the database at the WordPress-MySQL service name. So this is basically the complete view of our application from within the cluster. But we still need to expose our WordPress front end to external users. So how do we expose external users to services running within our cluster? Right now, the only service we have is a single WordPress MySQL service of cluster IP, and that doesn't do us really any good. We need to create a service type of load balancer to expose external users to the WordPress front end on some sort of publicly resolvable IP. And that's where a tool like MetalLB comes in. So unfortunately, there's no native load balancer service integration integrated into the Kubernetes code that isn't dependent on underlying infrastructure as a service hyperscalers like AWS, Azure, GCP, so on and so forth. So if we're deploying a cluster that is not utilizing one of those hyperscalers directly, we need to be able to provide some sort of solution that can provide the service type of load balancer to our cluster. So in the case of VMware Enterprise PKS, those clusters use the NSXT container plugin to create load balancers, NSXT load balancers, but we're not using that here in our VMC environment. So we need to create or deploy some sort of third-party solution to create load balancer type resources, and that's where MetalLB comes in. So as a quick aside, I want to talk a little bit about MetalLB so we'll understand kind of what role it plays in this deployment. So the network load balancers that are part of Kubernetes code, as I said previously, are tied to public cloud infrastructure as a service platform, so the hyperscalers. So MetalLB offers a network load balancer implementation that integrates with standard networking equipment. It's fairly straightforward. You can do, like in this example, we're just going to do simple L2 load balancing on an IP address. So the only requirements are some sort of Kubernetes 1.1.13 or later, some sort of compatible container network interface, which we're going to use Calico in this case, and then some available IPv4 addresses that we can dole out to MetalLB to create the resources. So we're going to use kubectl to apply this YAML file that the MetalLB team hosts on a public repository, which will essentially deploy on our workload cluster a MetalLB namespace a single controller deployment, and then a speaker daemon set, which a daemon set is similar to a deployment, but it just ensures that a pod is running on every worker node in the cluster. So in our example, if we have 5 worker nodes or 3 worker nodes, we're going to deploy 3 speaker pods or 5 speaker pods. So the controller is responsible for receiving and understanding a request to create a load balancer service, and it grabs an IP from a range and then doles it out to the load balancer service in Kubernetes. The speaker is responsible for talking on the protocol. So when a request comes in on that load balancer, there's a speaker pod on each node that is listening for requests on the specific IP addresses. So these pods and these services are not active until we deploy a config map that essentially tells MetalLB, what am I doing? What IP addresses am I using? So in our example, we're just going to use a range of IP addresses from our VMC routed environment to resolve and provide IPs to this load balancer service. So now we deploy the config map, MetalLB is active, we can hop back into the environment and create our service type of load balancer to sit in front of our WordPress front end so external users can access our WordPress application from without. So again, we use a selector to set our WordPress load balancer service in front of our front end pod. So that connects our service to our WordPress front end pod. Now our external users can access our application on that load balancer, but we need to be able to understand, what is our IP address. So we can use kubectl get services to observe our WordPress load balancer external IP, which is going to be the IP that MetalLB is advertising our WordPress front end on. So now we have an IP address that our users can access. Now, this IP address is internal to VMC only currently. So if we have developers that are accessing this environment from within a VPN that's connected to our VNC environment, they can access on this directly. But what if we have truly external users that are going to be coming in from the public internet, so they don't have VPN access? We're building, in this case, a WordPress application that we want the world to know about. So we can navigate to the VMC console or the cloud console and create a NAT rule for our WordPress site. We can expose, again, an elastic IP from AWS, that is our public IP. We can expose the HTTP service on that IP address and then map it to our internal IP. That's our MetalLB load balancer IP. So at that point, our users can navigate to our elastic IP, public IP that was generated by the NAT rule. We can use Route 53 or whatever DNS solution we have to set up a DNS record. So when our external users want to access our WordPress application, they can consistently access that at a resolvable, fully qualified domain name. So that concludes our session on deploying cloud-native applications and infrastructure on VMware Cloud on AWS. It's been a pleasure, delivering this content to you, and I hope to see you very soon.